Welcome to the DIY Honda Garage channel. The DTC P0107 indicates a low voltage signal detected from the manifold absolute pressure MAP sensor. The MAP sensor plays a critical role in engine management. It provides real-time data about the intake manifold pressure to the engine control module, ECM, or powertrain control module, PCM. Located on the intake manifold, this sensor helps the ECM determine the air density entering the engine, crucial for optimizing fuel delivery and ignition timing. If the voltage drops below the specified threshold, it can lead to performance issues, reduced fuel efficiency, and increased emissions. Diagnosing the issue accurately is key to restoring optimal engine performance and ensuring compliance with emissions regulations. The DTC P0107 error code signifies that the voltage output from the MAP sensor is lower than expected, particularly noted at a less than 0.23 volts threshold. The MAP sensor plays a vital role in the engine's operation by measuring the pressure in the intake manifold. This data aids the ECM in making necessary adjustments to the air-fuel mixture for optimal combustion. Positioned directly on the intake manifold, the MAP sensor requires a stable voltage signal to function correctly. When the voltage is low, it may indicate issues such as an open circuit, poor electrical connection, or a faulty sensor itself. It's crucial to address this issue promptly to prevent further engine performance degradation. Three primary factors could lead to the DTC P0107 error code. Firstly, poor electrical connections, such as corroded terminals or loose plugs, may prevent the MAP sensor from transmitting accurate voltage readings. Next, the MAP sensor itself could be faulty. Internal malfunctions can cause it to output low voltage regardless of actual manifold pressure. Lastly, an open circuit within the wiring between the MAP sensor and the PCM can disrupt the signal flow, resulting in low voltage being detected. It's essential to carefully inspect these areas during the troubleshooting process to identify and rectify the root cause effectively. Symptoms associated with the DTC P0107 typically include noticeable reductions in engine performance, leading to sluggish acceleration or erratic idling. Additionally, drivers may observe decreased fuel economy, as improper air-fuel mixtures can lead to inefficient combustion. The check engine light, CEL, will generally illuminate, providing an immediate alert to the driver that the vehicle's onboard diagnostics have encountered an issue. If left unaddressed, these symptoms can lead to increased emissions and potential long-term damage to the engine, making it essential to follow through with troubleshooting as soon as the DTC is detected. The first step in troubleshooting DTC P0107 involves turning the vehicle to the on position without starting the engine, and then using the Honda Diagnostic System, HDS, to check the MAP sensor's voltage output. The expected voltage should be at least 0.23 volts. Confirming whether the current parameter conditions match this threshold is crucial. If they do, you will proceed to the next step, enabling more precise diagnosis. If the conditions do not match, it may imply an intermittent failure, suggesting that the system could still function correctly at times, indicating potential issues with connections or wiring integrity. Thorough inspection of the MAP sensor and engine control wiring is necessary if parameters are not met. In this second step, you'll need to switch the vehicle to the off lock mode and disconnect the MAP sensor's 3P connector. After isolating the MAP sensor from the system, turn the vehicle back to the on mode. Using the HDS again, verify the MAP sensor's voltage output. As before, the measurable voltage should be less than the specified 0.23 volts threshold. If the current conditions match this threshold, the diagnostics will guide you to step 5. Otherwise, Proceed to the next troubleshooting step. This approach allows for isolating potential issues at the sensor level, which is crucial for accurate diagnosis. Step 3 requires measuring the voltage between specific test points at the MAP sensor's 3P connector, while it remains disconnected. The specific test points involve the female terminals within the connector. Point 1 is the number 1 terminal, while point 2 is the number 3 terminal. During this test, the expected voltage between these points should approximate 5.0 volts. If this is confirmed, it indicates that the MAP sensor is likely faulty, necessitating its replacement. On the flip side, if the voltage isn't around 5.0 volts, it prompts action to check further wiring conditions in the next troubleshooting step. Accurate measurement and interpretation of this voltage are critical for determining the sensor's operational status. In Step 4, the procedure begins similarly with the vehicle turned off, and then the technician should jump the SCS line using the HDS. After about 1 minute, disconnect the PCM connector E, designated as 80P. At this point, you'll be checking for continuity between prescribed test points in the system to ensure a proper connection. You will check between the MAP sensor's connection terminal number 3 and PCM connector E at terminal number 70. If continuity exists, it suggests that the VCC1 wire is intact and in good condition. In this case, it would be prudent to refer to any authorized service information related to the current DTCs or symptoms observed. If there's no continuity, however, it's indicative of an open circuit in the VCC1 wire, necessitating repairs to restore proper connectivity. The fifth troubleshooting step mirrors initial actions. First, set the vehicle to the off position and switch the SCS line respectively. You will then isolate the PCM connector E while checking for continuity between other specified test points. Specifically, continuity must be evaluated between the MAP sensor connector terminal number 2 and the body ground. A successful continuity check indicates the PB wire is intact. However, if continuity is confirmed, this points towards a short in the PB wire, demanding immediate attention to repair it. Upon identifying or repairing the short, it is essential to verify everything is functioning before closing the repair. Dialogue with authorized service resources would also be prudent for any lingering concerns regarding the DTC P0107 and its symptoms. After completing the troubleshooting and necessary repairs, it is essential to enter the final repair verification phase. Start by confirming that the original issue, indicated by the DTC P0107, has been adequately resolved. This includes thoroughly rechecking the MAP sensor's functionality to ensure it operates within the specified voltage ranges. Following successful verification, clear the DTC using the HDS and take the vehicle for a test drive under various operating conditions. Monitoring the system for any reoccurrence of symptoms or DTCs is critical to ensure all repairs have been executed correctly. A successful outcome initially demonstrates that the issue has been fully addressed and that the car returns to optimal performance. Preventive maintenance is essential in mitigating the chances of encountering DTC P0107 or similar issues in the future. Regular inspections of wiring and connections around the MAP sensor and PCM can prevent intermittent electrical issues that might lead to low voltage reads. Additionally, maintaining clean and corrosion-free connectors enhances reliability, ensuring consistent data transmission. Technicians should also monitor the lifespan of components like the MAP sensor, replacing them preemptively if signs of wear appear. Such measures not only ensure robust performance, but also contribute to long-lasting engine health and efficiency. In summary, the DTC P0107 indicates a problem with the map sensor circuit, predominantly showing low voltage conditions. Understanding the importance of the map sensor within the engine management system is crucial for maintaining optimal vehicle performance. Following structured diagnostic steps allows for accurate identification of issues, whether stemming from the sensor itself, faulty wiring, or poor electrical connections. Implementing preventive maintenance strategies can significantly reduce the chances of DTC occurrences in the future. Finally, ensuring a well-maintained vehicle not only improves operational efficacy, but also contributes to a more enjoyable driving experience. Please like and subscribe to the channel. See you next time.